Well, the biogas that you produce is very similar in composition to natural gas. It's a slightly lower methane percent on average, but basically anything that you can do with fossil methane, i.e. natural gas, you can do with biogas. Typically in developing countries that use these small systems, one of the primary uses is for cooking. They'll just siphon the gas right off the system and plumb it into their stove. And that particular usage really has a lot of public health benefits in developing countries, in particular in places that need to spend a lot of hours collecting firewood for cooking. It also improves the indoor air quality because there's no smoke that's generated from burning biogas. Other uses for that, there's biogas lighting that you can use. It's like the old propane lights that used to have in houses back in the 19th century. If you generate enough of it on a larger scale, there's biogas generators. You can produce electricity with it. Another project Dr. Martin worked on in Costa Rica, they were using the biogas to run a generator to power their milking operation during the peak mode. So basically anything you can do with natural gas you can do.
This is a gas flow meter here. Just accumulates the total amount of biogas we produce. So since October, we made about we have here 1,900 liters of biogas. It's gone up a lot more in the last few days as it's gotten warmer outside. The manometer, and it records the pressure difference between the pressure that's in the digester and the ambient pressure. So right now it's reading 3 inches. So right now there's 3 more inches of pressure inside the digester than there is in the outside right now, which means that there's biogas in there that's ready to be released. When we were out on Friday, I think we had 6 inches of pressure in there. So if we let this go for another few days, we'd probably get up to 6 inches or so. This PVC pipe right here is coming off the very top of the digester, and that's where the gas is. The gas is going to accumulate at the top of the digester.
Oh, okay.
And then from the PVC pipe, it follows this clear vinyl line up to where Juan's just about ready going to collect a gas sample. So there's a couple of things we do. We collect a gas sample so we can analyze how much methane, how much CO2 is in the gas that we collect, and then we also quantify the volume of gas that we're getting. So that bag is going to fill up right now. See it, but underneath these bricks is a 300-gallon tank. It looks like a submarine almost.
Yeah, well, that shuts off every half hour. It's a half hour.
You can, well, the digester, so if your digester is large enough, in our digester we have 100 gallons of storage potential. So we can store at least 100 gallons of biogas. So if you had a larger digester, say there was 1,000 gallons and you're using two-thirds of that for liquid volume, then you would have about 300 gallons of gas that you could store, or more, because it's compressed a little bit inside the digester. That's how the fixed dome systems operate in China and India. There's also another type of that system in Costa Rica, which is just a big plastic bag, and there again they just store the gas in the digester. Some of the systems in China and Costa Rica, they'll just have a big bag somewhere where they'll hold the gas in, so you can store it that way too. So there are some ways to do that. If you're going to use a generator, they need to pressurize the gas in some kind of steel tank and have a generator, and things get more complicated and more expensive pretty quickly. For the larger digesters that are on farms, they're producing a sufficient amount of methane that it makes sense to have a generator, so they take that methane and convert it into electricity. And so then they need to have a generator, which is a very expensive piece of equipment, but it does make sense at a real large scale. For the type of farms we're looking at that are maybe 100 cow dairies or a few hundred cow dairies, or at least I'm thinking right now that might not make sense, and it would make sense to just burn the gas directly to heat water. You could use that for the cleaning operations of dairies. You have to have hot water twice a day for most dairies, or at least one time a day. You could use it to heat a house. Anything you need to heat with, you can use this gas for. If you do convert it to electricity, you lose about, the conversion process is about 25 to 30%, 35% efficient. So you lose about 70% of your potential energy in that process. You do get a higher quality energy, which is electricity, but you lose a lot of your potential. So for a smaller farmer, we think it would make more sense to use the gas directly.